Hi, this is Greg Musin. I'd like to show you real quickly today a method that I came up with for figuring out electrical resistances in parallel. I haven't seen anybody else do it this way, and I came up with it while I was in Air Force Electronics School. I was sitting through it, the lecture, and they were showing us the typical reciprocal method of figuring out resistances in parallel. And I just thought to myself, there's got to be a better way. And luckily for us, it turns out there is. This way works every single time, regardless how many resistances you have, regardless what the values are. It works every single time. So before I get into that, I want to go over some basic things about a parallel circuit. Okay, the reason this is a parallel circuit between points A and B is because there is more than one path that I can choose to get from point A to point B. If I start at point A, I can go through this 5 ohm resistor and get to point B. I can also choose the next 5 ohm resistor and get to point B. Or I can go through this 10 ohm resistor to get to point B. That makes it a parallel loop. If these were all stacked, so I had to go through the 5 and then through the other 5 and then through the 10, and there were only one path, that would be a series loop. But because there's more than one path that I can choose, it's a parallel loop. One of the rules about resistances in parallel is the resistance between point A and point B will always be less than my lowest resistor. In this case, I have two 5s, but 5 is still my lowest resistor value of the 3, right? There's nothing lower. So I know that my R sub T, which is total resistance, okay, is going to be, once we find out the answer, okay, it had better be less than 5 ohms, okay? That's just kind of a nice little ways that we can double check our answer at the end, okay? So this is such a simple method that a lot of times you can do it right in your head, okay? You might need a calculator once in a while, but it's so much simpler than the reciprocal. All you do is this, okay? I take the highest value resistance, which in this case is 10 ohms. I'll write it off to the side here with a line under it. That's what I call the magic number. I don't know why I call it that, but that's just what popped into my head first, I guess. Then I take all 3 resistances and I ask how many times do they fit into the magic number? Well, 10 obviously fits in once, so I'm going to write a little 1 there. The 5 fits in twice, and the other 5 fits in twice as well. I then add these values up, 2, 2, and 1, which gives me 5, right? So it's 10 divided by 5. It's that simple. So the answer is 2 ohms. 10, magic number, divided by how many times all 3 of these go in, add it up. I don't know if that makes sense. So again, 10 went in 1 time. The 5 fit into the magic number twice, and the other 5 also fit in twice. I add all these up and I divide it into the magic number, and there's my answer. And if we double check it, it does meet our criteria also of being less than 5 ohms. So hope that works for you. There's my email address there. I'd appreciate some feedback if you could let me know if this helped you. Thanks for watching.